For this video, I will be solving an electron geometry and hybridization problem for General Chemistry 1215. Azides such as sodium azide, NaN3, are used in automobile airbags as a source of nitrogen gas. Another compound with 3 nitrogen atoms bonded together is N3F. What differences are there in the arrangement of the electrons around the nitrogen atoms in the azide ion, N3-, and N3F? Is there a difference in the hybridization of the central nitrogen atom? In order to solve this problem, we first need to determine the electron geometry of the azide ion. To do this, first we will draw the Lewis dot structure. First, we need to remember that the Lewis dot structure has a charge of -1 and thus will be in brackets, like so, with the -1 charge shown up here. That means it will not only have the 15 electrons from the 3 nitrogen atoms, but an additional one, bringing the total to 16. Then, once we draw the skeleton structure, we've used up 4 of the electrons, which is a total of 12 electrons remaining. Now we'll go ahead and distribute those on the exterior atoms, and now we've gotten rid of another 8, bringing the total to 4. Now the remaining 4 could go as non-bonding atoms on the outside of the 2 nitrogens here, or we could put them as double bonds here, which would result in lower formal charges and in the center nitrogen following the octet rule. So that's what we'll do for this problem. Now the formal charges are -1, +1, and -1, bringing the total formal charge to the -1 it's supposed to be. So for this molecule, what's happening here is we've got, for the central atom, only 2 items bonded to it. So it'll be a linear atom, like so, and thus we'll have a hybridization of sp. Now, next, we'll discuss the N3F electron geometry. Just as in the last problem, we'll start with the skeleton structure, which looks like so, and then we'll go ahead and count up the total electrons. We have 7 from the fluorine plus 15 from the nitrogens for a total of 22 electrons that we need to distribute. 6 of them have been used in bonded pairs already, and now we'll go ahead and distribute the remaining electrons like so, and then we'll have an electron pair either in a double bond here or in a double bond here, with the other one having an unbonded pair. This structure will look like so, accounting for resonance structures. Now, to draw it in its electron geometry form, it'll look like this, trigonal planar, which is an sp2 hybridization. So, to answer the question, the azide ion has sp hybridization, while the N3F molecule has sp2 hybridization. Azide has 4 bonded and 4 unbonded electron pairs, with the central atom having only bonded electron pairs. Comparatively, N3F has 4 bonded pairs on the central atom, with a total of 4 bonded pairs and 8 unbonded pairs. The azide ion has linear electron geometry, while the N3F molecule has trigonal planar electron geometry.